Hope you're all enjoying your final full day of this year's reInvent. Thanks for joining myself, my colleague, and AWS Principal Engineer, Shatak Sharma, who's going to come out last, and one of our favorite customers, VP of Database Platform Engineering at Fidelity Investments, Manoj Kumar, to hear about how Fidelity operates their Tier 0 trading databases on AWS. By way of introduction, my name is Stephen Clark. I, despite the red pants and the hair, am the Director of Enterprise Support and Technical Account Management for our global financial services customers here at AWS. And if you're anything like my customers, you're either running mission-critical workloads on AWS today, or you're probably planning to run some mission-critical workloads on AWS sometime in the near future. We're going to talk today, hopefully, about how you can learn from what we've learned and how you can successfully run those types of applications on AWS. By way of quick kind of introduction, many of you may tier your applications today. Some of you may not. Manoj is going to speak specifically about how Fidelity tiers their workloads. When we talk about Tier 0 workloads, we're talking about the types of workloads that have the lowest recovery point objectives, recovery time objectives, the type of workloads that when they go down, probably lots of people are going to get involved and your business is going to be at risk, right? So maybe we'll start with a quick question, given that background. I'd love to take a quick survey, not that I can see that well with the lights in my face, but raise your hands if you're currently running production workloads on AWS today or you plan to do so in the near future. Awesome. So you're all in the right place. That's good. Okay, now put your hand up again if those production workloads include the type of Tier 0 kind of critical applications that we're talking about. That's great. So hopefully this will be helpful for you. I think the main thing is when I started here 6 years ago, that probably wouldn't have been the case, right? But now, gone are the days when our customers are running solely generic IT applications on AWS. Right? AWS customers across all industries, public sector, private sector, are running some of their most critical applications on AWS. Airlines are running customer service and ticketing systems. Healthcare and life sciences are doing drug discovery. Media and entertainment, as you all I'm sure are familiar, are live streaming large events to tens of millions of people, right? Obviously, retail companies are running their whole online businesses on AWS. Financial institutions like my customers are now running their core business and customer-facing applications on AWS as well. And so when we look at real-time applications like stock and bond trading, exchanges, online banking, payment processing, insurance claims processing, those require real-time access, right? And end customers need those systems to be up and running, all of us in the room, right, to do things like trade in our retirement portfolios, but to also be able to do things like pay for the coffee that I had before this, right, and go out to eat. Now, disruptions to systems are obviously costly, as we all know. IDC actually did a recent study of this, and they found that enterprise organizations run into, on average, 29 outages, unplanned outages, every year. The average outage takes about 5 hours to resolve, right? And that total cost just in managing those outages is $13.5 million a year. And that's before we talk about like the brand impact, the reputational damage that maybe having your most critical systems down for some period of time has on your business. So what does managing an incident look like today? One of our banking customers ran into an issue with one of their customer-facing applications several months ago, and they spent 4 hours trying to kind of triage the issue, figure out what was going wrong and what to do to solve it before they ever reached out to AWS for help. Once they did, we were able to help them make a configuration change. The problem resided on their side, and then they were back up and running. But 4.5 hours was way too long. Right? You don't want these kinds of critical systems to be down for that long. So what customers like you are telling us is that you run into 3 major problems. Right? Number one, in many cases, you don't actually see the problem until your end users tell you about it. And that's a problem whether you run on the cloud or you run on premises. It's just the feedback loop is coming from the end customer. Number two, you struggle to identify the trigger for the problem. So particularly when you're running on the cloud, is it your own application code? Is it a change you made? Is it your AWS infrastructure? Is it some third-party service that you're using, right? Those two problems in and of themselves are just that alone. We see our customers take like 2 to 4 hours to get through that process many times before they come to us and say, hey, can you help us out with this? The third thing is just that like you simply can't solve these critical problems fast enough, right? And we all know you have a host of tools that you're using to do that today. You may have monitoring systems in place. You're using AWS native services like CloudWatch and X-Ray. But it's that alignment as well between those systems and what the impact is to your customer, how to overlay those capabilities together that's challenging. And in a typical incident, we see customers run into basically two scenarios. Either they've got a ton of noise. They're getting lots of alerts and signals from many different sources, and it's hard to figure out what that means. Or honestly, they just don't have the observability that they needed to see that this problem was coming. So the other piece, actually, since Fidelity Investments is going to be out here, I think we wanted to talk a little bit about the specific challenges that financial institutions face as well. So, and this is not specific, I mean, there are specific regulations to financial institutions, but I think overall in any regulated industry, there's another set of challenges, right? Given the critical nature of these apps, regulators around the world are introducing or already have existing regulation that applies principles, in many cases, principles-based regulation, whether you're running on-prem or you're running on the cloud. A good example would be the EU, the European Union's coming out with the Digital Operations and Operational Resilience Act. It kicks in January. And that's, again, it's not a strict and prescriptive set of guidance, but it lays down some principles that customers need to follow. And one of the key components of that is that the regulator needs to know when there's a problem, so they need to know that you've been impacted. And then in certain timeframes, in this case 4 to 24 hours, you need to be able to tell your regulators what the impact is and what you're doing about it, maybe even before you've actually resolved or mitigated the issue. And they need to know that you can do that, not just after a problem happens, but you need to be able to evidence that you have those processes and controls in place beforehand. So, given these sets of problems, we started partnering with customers 5 years ago, but we've partnered with customers like yourselves, with Fidelity, to build a new set of services that we launched 2 years ago, AWS Incident Detection and Response, to help address these issues so that you can shrink the 4.5 hours of downtime that we were talking about to 30 minutes, or even better, eliminate it altogether, right? So what does IDR do? It does 4 main things. Number one, these systems are complex. We want to improve that observability. So to do that, IDR helps us define and correlate metrics and alarms between your application and the business impact and the underlying AWS services that you're using. We want to be able to detect things early, right? Then we want to speed up the resolution time. So rather than spending a bunch of time figuring out who to pull in to solve these problems, we build basically, we define ahead of time runbooks that we can use to respond to these incidents, and we respond to them within 5 minutes. And we'll respond to them within 5 minutes, ideally in the case where you have alarms set up and you're sending them to us, and at worst, if you don't have that alarming in place for that particular scenario, you can reach out to the incident management engineering team, and they can engage with you there. Those specialists are going to use those predefined runbooks that they're going to develop related to that alarm and also to your specific application, and provide single-threaded ownership of the incident all the way through to resolution. Now, because we have that context, when we have AWS events, we can also see whether or not that event that we're investigating on our side is having an impact on your applications as well, because we have that visibility. And then we can engage with you, and our specialists will reach out, notify you that, hey, we have an event going on here, we're investigating something. Your application is either impacted, we can see it already, or we don't see it yet, but we can now work with you on what's your mitigation plan for a potential impact to this particular service that you're using. And then lastly, our end goal really is to reduce that potential for failure. So we want to catch everything beforehand, have all the right processes in place to avoid these incidents, but when we do have them, those incident management engineers are going to work with you post-incident to go back through, did we have the right alarming in place? Did we have the right response plans in place? Did we mitigate this as quickly as we could have, right? And continuously improve that process. That's the goal of the service, but you don't really want to hear from me so much probably. You'd probably much rather hear from a customer who's using it. So I'd love to invite to the stage Manoj Kumar from Fidelity to tell you about how they're operating their Tier 0 critical databases on AWS. Thanks, Manoj.
All right. Hello, everyone. Thank you, Stephen, for the introduction. So my name is Manoj Kumar. I'm with Fidelity Investments, based out of Research Triangle Park in North Carolina. Anyone here from the Raleigh-Durham area? All right, cool. All right, before we get going on our topic today, I want to spend a few minutes talking about Fidelity. The Fidelity's culture set the scope and scale for what we're going to talk about today. Be better if I move the slide forward. Fidelity, founded in 1946, the mission twofold. One is customers' financial success, and two, employee growth and satisfaction. One of our leadership principles from a chairman is customer obsessed. So you can see that the products and services we deliver from Fidelity, we put customers first. So if you've been a user of Fidelity's products, you would have experienced that. So I'm proud to be part of Fidelity. At Fidelity, my role is database engineering and automation, responsible for deploying resources in cloud and on-prem in a safe and secure way. I also have dotted line responsibility with operational excellence, and that's why I was happy to work with Shaz and the AWS team to bring IDR service to Fidelity for our mission-critical workload. So these are some impressive numbers. 51.5 million Fidelity helps more confident in the financial goals. 28,000 employees by managing their benefits. So Fidelity, as you all know, it's got brokerage and 401k and all that, but besides that, we are also big on defined benefits, pension, stock plan services. We do student loan management, healthcare, Medicare services, and a lot more. So all of these require a lot of integrations with technology, and that's why technology is a huge portfolio in Fidelity. So 8 years ago, we embarked on the cloud journey. From the beginning, we decided to go with 2 cloud providers. Also, the technology choice, we wanted to bring in cloud agnostic tech stack and also focus on open source as much as possible. So we have 6,000 databases. Moving databases from on-prem to cloud is not an easy journey. I know some of you all have gone through the same experience, and along the way, we learn from it. Besides technology, Fidelity also invests a lot on our associates learning. So we dedicate 20% of our time on learning, upskilling so that the engineers are ready to embark into the new journey by learning and outcome-driven learning. This also has enabled us to contribute back to the community through open source, which I mentioned that Fidelity is focused on that. So overall, it's been helping us to attract and retain top talent. So overall, a great story. So moving on to our current discussion topic for today, resiliency, setting some foundation basics here. Resiliency is the ability to recover from a workload disaster. We all have experienced that in one way, shape, or form. Resiliency is measured through disaster recovery capability. One is RTO, recovery time objective, and RPO, the recovery point objective, and of course, the availability, which is the uptime. Double-clicking on RTO is your window between the time of impact to the time of recovery, right? How quickly can you recover from an impact? And that's a primary goal if you're running a mission critical. The shorter the window, the better for your mission critical workloads. RPO, on the other hand, is the appetite for data loss. How much data loss can your application incur? Obviously, zero data loss for mission critical. We don't want any data loss because from a trading platform perspective, if you're putting a trade in and if you have a situation and you don't see it, you're not going to be a happy customer, right? So that's very important for us, and availability is the uptime, as I mentioned. Tier rating, on the other hand, is the business entity driven by RTO, RPO, and availability. One thing I want to mention is when you say tier rating, you want to make sure your tier rating is from the top-down stack. You don't want your applications to be at tier 0, and you leave your databases to be at a different tier because you're as good as your weakest link. So let me quickly go through some of the patterns. The active-passive backup recovery restore is a foundational, fundamental. But if that is going to be your means of recovery, then you're not going to be a mission-critical application for sure, because that's going to take some time. The second one, which is active-passive, this provides some level of availability because you have a secondary site ready to take traffic, but still you got to bring that up and rotate the polarity of your replication. All of those, even though you automate it, you're not going to get a near zero RTO. And definitely RPO is based on your lag, right? Depending on how much of workload that happens during the time of impact. So the patterns that we're going to focus today are the active-active and the global active-active. Active-active is you have two region deployments, for example. Both of them are taking traffic, and there is a replication that is keeping both of them in sync. You can have applications hitting both of them at the same time, or you could go in one direction and keep the other one ready to take traffic. There'll be limited overhead in terms of connectivity if you configure it right, and the replication is bidirectional. This is a good pattern that meets most of your RTO and RPO needs, but definitely there's also a potential for data loss in this case because the replication is asynchronous. So depending on when the impact hits you, depending on the lag you have between the primary and secondary, dictates the amount of data loss and how much you have to recover the data. The other pattern, which is the global active-active. This is more of a modern relational model that is deployed across minimum of 3 nodes. And this is there are multiple vendors out here in the conference talking about these products. So we have been we have implemented this model for some of our tier 0 workload. What this gives us is it's shared nothing infrastructure. There's database that spreads across together and guarantees data replication and also strong consistency. This automatically gives us the data protection we need. If any impact happens to node 1, the data is guaranteed because it's a synchronous replication. So these are some of the patterns. Each of you may have used one of those for sure, depending on your tier rating, because the choice of these depends on your tier rating and what's the level of tolerance you have for RTO and RPO. So next slide, we'll dive deeper on our active-active pattern. This is based off a relational database running on AWS EC2. There may be other options we have on RDS, but when we developed all these patterns, RDS, even though it is available with primary and read replicas, a true active-active that can provide a cross-region failover, the options were very limited, and it didn't meet our tier 0 requirements, which is near 0 RTO and 0 RPO. So this is a 2-region deployment. I don't want to go into details on the application traffic routing. Fidelity's traffic routing is pretty complex and robust, rules-based. There's a separate discussion that went on earlier, and you can look that up. And this dictates where the traffic goes, whether it's going to your cloud platform or to your legacy platform, because we still have a legacy platform. Remember, we are trying to modernize our trading platform, moving it from the legacy to cloud. And this is the journey that we are going through. So when we started the journey, we embarked on this active-active pattern, which made sense for us to meet the tier rating requirements. So this is deployed across 2 regions. you have the app server clusters, we run Kubernetes, and then you have the load balancer. And as you can see, we have two primary databases in East 1 and East 2. Both of them are taking traffic. And then you have a secondary database that is on zone 2 in each of the region, and that is for your failover. The moment the database traffic manager detects that it's not able to get to the database in zone 1, it automatically switches to zone 2. Likewise, the same thing on the East 2. And the way we keep all of them together is through replication. So this replication is going always, 8 ways, keeping the data in sync across all of them, so all transactions are kept in sync. Obviously, with this pattern, you got to make sure you have conflict resolution and some of those taken care of. Otherwise, you're going to get a lot of collision. And then we also have two other databases on the side. If you can see, those are standby. So in case of a primary database getting into a corrupt state that we could not recover for some reason, we can switch that standby to primary without having to go to a backup and recovery. So we went through a lot of level of details into this to architect this together. Even though we have done this and it meets our tier 0 requirement for the most cases, there are a lot of challenges. One is it's not highly fault tolerant. Second, it doesn't provide us horizontal scalability. And number 3, data loss. There's still a potential for data loss in this case, even though we run a pretty tight replication to the point where we can guarantee replication is within a second for 98th percentile. There are still scenarios where if the database goes down during market open, there is potential for data lag, and that we have to account for, and recovery from that takes time. So although we were able to migrate our workload from on-prem legacy to cloud, we were not convinced that this is going to enable us to accelerate and completely go into this pattern. Moreover, this pattern, we ran into some of the challenges as well between communication from the database to the storage layer, few other nuances. So this put us into a point where we need to look deeper into something else that can solve the problem, which will give us the 0 RTO and 0 RPO. And this is where we went into the distributed relational database model around 3 years ago, 2.5 years ago. This is a cloud-native relational solution. As we said, this is deployed on a 3 region in our case, but at least you need to have a 3, it should be deployed in 3 nodes for a minimum to ensure that you can have a zone failure, to handle zone failure. So this is a 3 region deployment. Or before that, the distributed database is based on the Raft consensus protocol, where it guarantees data replication and also a strong consistency. And those things are handled by the product. The stuff that we were handling through replication, 8 ways, and all that in the active goes away. So this is part of the product, and this to us, based on a 6 to 8 month of rigorous testing, gave us the assurance that we can deploy our mission-critical workload in this pattern to get the real-time failover capabilities, and also when we have a failover, we will not have data loss. Because of the strong consistency, it's 0 RPO, and that's guaranteed. So at Fidelity, we have a 27-node deployment across 3 regions. One of the concepts with distributed database is your replication factor. This is deployed with RF5. What that means is every subset of data, whether it is a shard or a range or a tablet, whatever you call it based on the vendor, it's duplicated 5 times. So in an RF5, you have 5 copies of the subset across the 3 regions. So in an ideal state, in East 1, you'll have 2 copies. In East 2, you'll have 2 copies, and West is 1. The West region, if you have noticed, we don't have any app servers running, because Fidelity is East 1 and East 2 based for latency. The West is mainly for, we call it the witness region or the quorum. To maintain the quorum is where we have that. So in an ideal state, there's 2 copies in East 1, 2 copies in East 2, and 1 in West. So it can tolerate node failures and also a complete region outage. The moment you lose East 1, we still have 3 copies that will provide the quorum for the cluster to work. Internally, it is the responsibility of the product to ensure that the missing copies are moved over if East 1 does not come back in a reasonable time. Once East 1 comes back, everything else manages itself. This has been very effective for us. We have tested this out completely. And you may question why this complexity. And I would say that this goes back to our customer obsession, which I mentioned before. We want to make sure that any customers who comes to Fidelity's platform, whether you're trading 1 stock or 10 stocks or 1 million stocks as an institutional, we want to have the same experience. We want to make sure that you come in at 9:30, you have an order to execute, and that order executes. And right before leading up to the elections, the market could have gone down or up, whatever it is. So we have to scale out the cluster, and this provides the horizontal scalability, which is real time. We don't need to bring down the cluster or whatnot. It all adds up behind the scenes. So we have done a robust automation to execute some of those tasks. So these are the 2 patterns. Again, these are all running on EC2s. There's a lot of cost and other complexities involved. So I would definitely, if this is something that you're looking for your application for tier 0 workload, you may want to consider some of these patterns. So we talked about the resiliency patterns, and now it's why are we doing it? Back to the question of stuff happens in the cloud or on-prem or wherever you run, infrastructure do fail. And this is a famous quote. We have all seen that. So now that we have built a resilient system, how do we know that the system works when we need it? We can wait and watch for it to happen and then react, or we can do something proactively. Fidelity, once again, being the leader in that space, we want to make sure we test it before we go into prod. This is where I want to lead you into the failure mode and effects analysis. This is an industry standard. It's not anything new for Fidelity, but we embraced it and we built on top of it. What is FMEA? FMEA is your proactive way to test some of the failure points by manually injecting those failures. How we do it, we can use the AWS fault injection service. It comes with a lot of the hard and soft failure built in, and some of those are customized scripts. And then we have automated all of those through a framework called Chaos Buffet. There was a presentation, I think, yesterday or day before on the same topic from Fidelity. So you should look that up. So this, we take it seriously. We run through all of our scenarios on the compute side, the storage side, the memory, pressure. And all we are trying to do is, what happens to the database? Does it fail over? If the database fails over, how does the application handle it? How long do they take? So if you know all of those details, then your business knows exactly what they are getting into. And when the event happens when you go live, there's no surprises. And we are constantly learning from this. We are constantly improving this, and it's a constant feedback loop for us to mature our products and services. All right. This is our tying all of those things back to our mission control. If you have built a system, you need to support it as well. And this is our Fidelity Support Center, where all of the telemetry from all of our applications and database goes up to this division that monitors all of the data points to ensure that we quickly react to it, we quickly mitigate it seamlessly. They have the controls to mitigate as well. And once we mitigate, we got to get to what happens with root cause, what caused it. And we do it with a with a no blame attached, go together as a team to understand where the failure happened and then learn from it so that we can prevent a recurrence. So the question now becomes, I know the topic is also related to IDR, incident detection and response. So if you have built so much of resiliency into a system, we are testing it, and we have a robust operating model within the company, why do you invest in IDR, right? So honestly, when we embarked on this journey to put this complex application in the cloud, we ran into some challenges. We ran into some issues, and then engaging with AWS team, AWS support team, was challenging. It took some time to get to the right folks. I don't know how many of y'all have experienced that, but it's not easy, right? They have different expertise, different SMEs, and working through this channel takes time. But we're talking about mission critical. We have mitigated it, but we still want to get to the root cause, and we go back to prod normal as soon as possible. So this is when I was introduced to the IDR by Shaz and the team. So when we looked at it, imagine if you have a system that the AWS support team knows exactly your topology, how you operate it. They know exactly your SLAs that you're working against. And all of the alerts that your internal teams are getting, it's also ingested back to AWS. So that's the level of service that Fidelity is looking for some of our mission critical. It's not for everything, but for mission critical, where you have that complete handshake that when you have an incident, it's not that we have to go reach out to AWS. AWS, contractually, they are obligated to reach out to us. They open a phone session and they engage the right groups and everything because they are getting all the alerts. So it's been a year, I would say, that we have onboarded the service. We have been working together and learning some of those things, and there's room to grow for both. But I would say that we have realized good value out of it already. So with that, I will turn it over to Shaz to dive deeper on this IDR topic. But definitely, I know you may have some questions and such, so we'll be around here after that to catch up. Thanks for joining. Cheers.
Thanks so much. Yep. So hi, everyone. I'm Shatak Sharma. Also, I go by Shaz. I'm a Principal Technical Account Manager with AWS Enterprise Support. And you all heard from Manoj on the care and the due diligence that Fidelity takes to build and operate their workloads on the cloud. So, and you also heard a little bit about why IDR. I'm actually more here about how did we end up with IDR for Fidelity, right? So in this scenario, it all goes back to one fateful day. I think we all, as part of IT, we have gone through a phase where we get that one incident that kind of burns a lot of calories across the board, a lot of hours. And this happened to Fidelity as well. There was a tier 0 database. And while I go in, it's important to differentiate between what a hard failure looks like and a gray failure looks like. I think we have reasonable observability for hard failures, and we can map that to our response plans. But when you have a distributed architecture, critical applications, we want to make sure we can isolate the noise from the exact signal that's causing the problem. So continuing with the theme of how we got here, this is an incident where right in the middle of the business day, 12:25 p.m. Eastern, Fidelity notices the errors at the application layer. Now, they have really good circuit breakers. I think within one data point, they were able to route the traffic away from their primary region itself. So the business impact is mitigated. But now, being in the financial services space, Fidelity wants to make sure they understand what happened, what was the cause, so that they can figure out what the risk is. Even though they have routed the traffic away from one region, they are ready for market close or market open the subsequent day. So in this scenario, while they detected this anomaly, they spun up their own ITIL teams, which we heard about. They went through a triage process. They're isolating the noise. There are a range of signals that are coming in. And they have multiple stakeholders engaged at this point of time. So while they're dissecting some of these signals, at a decision point, they decide to engage us. So around 1:35 p.m., they open up a high severity critical case for AWS support. And we join the incident by 1:48 p.m. So for simplicity's sake, we're going to call this initial engagement. Now, when we get onto a bridge, the way our support works today is we have swim lanes, right? So the initial possible signal that they want to troubleshoot in this scenario was compute. We've jumped on a call, and then we quickly realize it's high impact. We want to get to the bottom of this as soon as possible. But then there is time taken for us to understand the context, how this is impactful for the customer. So while we started the investigation on compute, somebody said on the bridge, oh, looks like we have a broader networking issue. So we engage our networking SMEs. While we are working through it, we're like, oh, no, maybe there's an issue on the storage as well. That's how gray failures work, right? We have to figure out which one it is. So you spend time on the storage triage. And while we are doing it, Fidelity is trying out some things on the compute space, and then we realize, oh, even though we don't have an actual signal, but there is an anomaly on the compute side. So we spend extra hours over there to recover this specific instance. Now, if you look at the overall timeline, we started at 12:25 p.m., and we ended the triage at 9:20. So even though there's no business impact, we want to make sure we are ready for the next day, right? Now, if we look at the key observations or summarize some of the data metrics which we thought we could help with, the time to engage AWS support in this case was 70 minutes. Time to identify the impacted AWS resource with the joint collaboration, the triage, was 5 hours. And then to sum it up, the total triage time is 9 hours. Now, when you look at these 9 hours, this is spread across like 50 stakeholders from the customer side, a lot of engineers on our side. So it's taking valuable hours from your time where you could be productive. You could be doing something else rather than jumping on a triage call and helping out with the issue, which may or may not be related to your area itself. So this is where we started working with Fidelity. We said there should be a better way to triage these and partner with you and support you on an ongoing basis. So we started working on the onboarding of the workload on IDR itself. This process is divided into 2 phases. The first phase is we work with you to understand what the workload is. We create a high-level response plan. So in case there is an issue, we know we don't waste time in understanding what the workload is, what the impact is. Let's get to the bottom of it. Let's get the SMEs that we need to help resolve the issue. This gives you a 5-minute response SLO for your critical cases. And then you have a single-pointed incident management for your critical cases. Now, the fundamental difference here is we are not asking you to open up a case for a specific queue/service with all the details. We're asking that, OK, on a reactive basis, you can open up a case to IDR itself. So as part of enterprise support, if you go to the support console, you are able to look up IDR. You can directly open up a case, and you get that 5-minute response SLO. Now, while this is good from a reactive basis, we move on to the next phase. This is where we jointly work through the impactful alarms that mean impact to your workloads. Now, the intention is not to onboard every metric, every alarm. We are trying to cut the noise. So you want to sit down, understand what is the business KPI you're working with. And we also understand that you're not just tracking business KPIs, you have already quantified what technical metrics mean business impact to your workload. So we can map those out and ingest these alarms on our side as AWS support. So when these alarms goes off, we're not waiting for you to reach out to us. We are building internal triggers to open up these triage cases, critical cases, automatically on your behalf. And then we are executing the runbooks, the response plans that we are aligned on, and we're reaching out to you. We want to make sure we cut the process, the elongated process that we saw in the previous timeline, as much as possible. So that's the process, but this is the integration that you see. Your workload could be anything. Any service, any metric that has a value we can ingest. It can be across the accounts. It can be a single account. So we are flexible. We want to make sure that we can adjust our response plans based upon your needs. So that extends into the observability aspect as well. We can ingest alarms from CloudWatch, Amazon CloudWatch, or it can be third-party APMs as well. As long as these APMs can support event bridge integration or webhooks. We have detailed patterns that we have built, which you can refer to on how to integrate these APMs into IDR itself. But when these alarms goes off, these are ingested in our IDR system, and then we cut these cases, we send these notifications out, and we work with you to kind of resolve the issue itself. To summarize the work that we did with Fidelity, looking at their architecture for active-active, multi-region setup itself, we worked with them on enhancing their observability on the compute space, the storage space. But there was one interesting finding that we realized. As they rely on data replication across the regions, the network latency becomes a critical piece in their success. So we worked and engaged our observability experts and worked through network manager and specifically infrastructure performance management metrics to align and ingest these metrics. So when, in case the latency goes up, we are checking with Fidelity to ensure that they are able to process their transactions and if there are no concerns or anything that we can do to help with. On the second pillar, we worked with them to make sure we were aligned on what the faster resolution looks like. We are providing a single-threaded ownership through the incidents. You don't have to ask us, or we are not asking you actually to open up separate cases across separate queues. That's all managed. And these, as I mentioned, runbooks are highly customized. And then we are providing fast-track access to the AWS experts on our side. The third thing that our customers asked for is, it's good that, okay, you see, we have an anomaly and you're trying to help us out. How are you going to help us out when there are AWS events? Now, we are not able to provide expedited recovery for your specific workloads in the events. However, we are providing you early warning signals through health notifications from IDR saying that, okay, you're operating your critical workload in this region, in this AZ, and apparently looks like there is a possible event that may impact you, right? And it can work both ways. Like your alarm goes off and you're trying to inquire, oh, is something going on in AWS? You get that answer through IDR itself so that you can figure out you want to execute your failover plans, DR plans, or you want to run as is because now we have confirmed that it's just an anomaly. The last piece is where we're trying to make sure that we reduce the potential for failure itself. As part of the IDR process, we conduct a post-incident review where we work through the whole of timeline on what happened, how did we respond, how do we improve some of the response plans on the ongoing basis. And of course, as part of our collaboration, we also do resilience evaluation. We try to provide you best practice guidance, and we work with you to figure out what the gaps are, which we want to make sure you're long-term successful on AWS itself. Now, I won't say luckily, but as Fidelity onboarded to IDR, as a fast follow, we had a similar, not exactly the same incident, but a similar incident where their alarms went off at 3:33 a.m. Eastern. Now, why that's important? There's no active traffic on the database right now. But Fidelity wants to make sure they're good to go for early trading hours in the morning, right? So we can't waste time. We have to resolve this quickly so they can assess how much capacity do they need for their business day, and we can give them and we want to make sure we do that quickly as possible. So what clearly you can see, like the timeline scope, it's a lot shorter, but high-level metrics that I want to highlight here is that in this scenario, with automatic triggers through IDR, the time to engage AWS support is 1 minute. So we are down from 70 minutes to 1 minute. Now, second metric is time to identify the impacted AWS resource. That's 42 minutes. The third metric is total triage time is 1 hour, 10 minutes. So we're done by 4:59 a.m. Eastern, and Fidelity can go back to what they were planning to do for the rest of the day, which is processing the transactions that the customers are putting in. Now, the second and the third metric, I've mentioned that as in amber, because I think there's room for improvement. We could do better. And that's where the post-incident review process comes in, where we still review on how did we do this triage, what could be done better, and we can optimize some of these processes or engagement times from our SMEs. We could load that context much quicker than what we did here. But it's still approximately 8 hours of triage time saved with this process itself in this scenario. So with that, I would like to thank Fidelity for their partnership and collaboration in helping us build this. We are continuing to work with them on additional edge case scenarios where we can optimize the incident management processes and give them better response times, better resolution times for some of their incidents. We will have Q&A after this session itself. You can scan the QR codes for next steps, some details around incident detection response. You can learn more about what Fidelity Investments does. But with that, thank you all for attending the session.